Alright, this is another review assignment. So it kind of will walk you through a lot of things about the carbon cycle that we have not covered on the previous notes. So right here is the assignment. So if you click on it, it will take you to this is assignment. So it says follow along the notes. So the notes are right here. You can just start right there. And then it says this will be more as a review before the quiz. So we're gonna take some time to review because the carbon cycle unit was pretty long. It covers both molecules and energy. All right. So where is carbon found? So you're gonna go right here. There you go. So you can kind of just go through the slides right there. So level 2 questions are straight from the PowerPoint. So these are all level 2 questions. They're gonna come straight from it. Level 3 questions will follow the PowerPoint, but you have to make connections to science. So you may not be able to find these answers as it is for level 3, but you're gonna have to try to make some connections between that and real life. And then for level 4, you have to basically be able to apply the concepts of the presentation. So you can see where's carbon found, and you have the slide right there. What is happening to the levels of carbon dioxide throughout time? So you look at this next graph, right? This is how you read a graph. You read the title. It says what is happening to the levels of carbon dioxide throughout time. Then you kind of come like almost like clockwise, like you're reading a clock, and you see these numbers right here: 58, 60, 62, 64. And if you notice, all these numbers corresponds to the number of years in the 1900s. That's what it says. That's kind of how you read. So you read the title, and you can skip all the way to the bottom of the graph. It says 58, 60, 62, 64, 66. So that's 1958, 1960, 1962, all the way to the 2000s. Then you have kind of like a clock right here. You look at these numbers over here on the side. That's the third thing you do. And these numbers are like some really random numbers, but it says CO2 concentration in parts per million, which means that out of 1 million molecules, how many are CO2? So if you had if you had 1 million molecules of air, so if you put 1 million molecules in a balloon, for example, how many of those 1 million will be CO2? So let's say, for example, you have a balloon, and in your balloon you have 1 million molecules. That would mean that 310 would be CO2, 320 could be CO2, 330 could be carbon dioxide concentration. So that's kind of like the amount of molecules that you will find in 1 million total. So for example, in a class with 30 students, how many would have a black hoodie? Or in a class with 1 million students, how many of those students will have brown eyes? Kind of the same idea. So in a million molecules, how many would be just CO2? Because you are gonna have other molecules like water vapor, you're gonna have argon, you're gonna have dust particles, you're gonna have a lot of other different things there. Okay. All right. So what is going on to the levels overall? Like, just don't overthink it. Just kind of like answer that there. And then what could be making the CO2 levels increase? So if you notice, there's an increase right there of CO2 levels. In the 58s was 315 carbon dioxide molecules in 1 million. And now it's looking like the closer you get to the 2000s, you're jumping from 315 to 365 for the concentration of CO2. So it's a big jump in just 50 years. So that's kind of what you gotta like write down there. Okay, and then the next one is carbon. What I said, you just keep going, right? So what is carbon, right? And then why is it called the building block of life? So why is carbon called the building block of life? And you can find the answers in the next part. So again, like it's just gonna go through the same slide. So next section is carbon. Where is carbon? So there's the next slide, right? So where does carbon go? You have all these different 4 places in which you can find carbon. This is 1, 2, 3, 4 different places in which carbon can be found. So you gotta write them 4 there, the 4 of them there, and then just keep going. So you're gonna have to look at the graph, just kind of study that for level 2. Why do we say that carbon cycles? And then and you look at this picture, and you're gonna be contrasting these 2 pictures and figuring out what is different, what is included in the global carbon cycle that is not the same. If you look at this picture right here, this carbon cycle right here model, this carbon cycle model right here looks more like a first grade level carbon cycle, kind of like an elementary level. This one right here looks a little bit higher level, maybe like third or fourth grade level, um, maybe fifth if you're including like some of these vocabulary words. But it's a little bit increased level, but it's not just the level. There's something that is including in the global carbon cycle that is not included in the normal carbon cycle that everybody just draws on their, on their first grade notebooks. And then just go ahead and just keep going through the slides. Again, you have to go through the slides even for level 3 and level 4, but you will have to make some connections there. So you have to study a lot of the graphs, a lot of the pictures, read through it, and try to make sense of what's going on and try to make some connections, especially this graph right here. Gotta really look it up. Again, you don't have to look at this little tiny picture. You can go to there's bigger pictures on the slides. So you go to the slides, you can probably like find like a much bigger version of that same graph or same picture. And then for level 4, you just gotta have to like apply the concepts that we have learned. Like why do we care? Like you as an 8th grader, why should you care about the carbon cycle and what is the impact on both, generally in the land and in the oceans, and what can we do to reduce carbon dioxide emissions, and why do we say that? For level 4, there's a specific part right here. What can we do to reduce CO2 level emissions? I'm not expecting a let's all ride bikes to go to work, or let's stop polluting, or don't cut trees, or recycle. Those are 3rd grade level answers. You are in 8th grade. You're gonna need to write better solutions because your solutions may create more problems. For example, let's all ride bikes to work. That will create a problem because now try to convince half of Utah even to ride their bikes to work. There are people who can't ride their bikes to work because they have disabilities or just health issues, as well as many monetary issues as to be able to buy a bike, or maybe their work is really really far away. They have to take the bus. Let's stop polluting, right? You can't really ask McDonald's to stop making their bags, or you can't really like there's more problems there. You can't ask people to buy paper straws as opposed to plastic straws, right? Like there's, I mean, you can, but it may create more problems because then you're gonna have a backlash of people not wanting it. Then probably more trash being made because now people think like, oh yeah, like paper straws can be biodegradable, so I can just throw them anywhere. So it just creates more pollution. Recycle, right? A lot of people actually don't know how to recycle, so just writing the word recycle is not enough. For example, water bottles. If you just grab a water bottle and just put it in a recycling bin for water bottles, that is actually the wrong way to recycle. In order to recycle well the water bottles, you have to take the cap off and take the little plastic ring left on the neck of the bottle, and then you just recycle the plastic, the smaller plastic. You have to cut the ring because that ring on its own will create more problems later. So again, like there's a lot more than just, I mean, don't cut trees, right? Like you can't make a law for every single country in the world to don't cut trees. There's people who rely on this financially. There's big corporations that rely on this, but also you kind of get into international law in which you cannot make laws for other countries. Other countries allow, or allow are more flexible, to put it nicely, to allow some illegal cutting of trees or over deforestation. So you got to make sure that you think about before writing like one word answers. You have to write good solutions, not just one word, one sentence is not going to be enough because you're going to create more problems than solutions. And that's it for this. So thank you.